Welcome and thank you for listening to this Paragon Edge audio blog. Picture an advanced function ATM mid-transaction. The card reader initializes, EMV kernels negotiate, cash handling devices respond in real time, and fraud or personalization logic is evaluated, all coordinated through CNXFS services. In this environment, Windows is not just an operating system. It is a foundational dependency that influences timing, service behavior, device drivers, and middleware interaction. Every Windows patch, security baseline update, or OS upgrade can subtly alter how these components behave. And for advanced function ATMs, those changes are rarely isolated. Historically, ATM operating system upgrades were treated as discrete initiatives. Teams would plan the upgrade, validate core transactions, deploy the update, and then move on to the next project. That traditional model no longer holds true. In 2026, advanced function ATM deployers face continuous OS change driven by several factors, including security patch cadence dictated by InfoSec teams, Windows 10 LTSC lifecycle pressure, and future Windows 11 considerations, evolving security baselines and hardening requirements, and middleware or device drivers that often lag behind OS updates. What was once a traditionally managed upgrade project has become permanent operational drag. Why OS changes are so risky for advanced function ATMs. Advanced function ATMs differ fundamentally from traditional state SAN screens machines. They are stateless at the application level and depend on the real-time behavior of XFS services. This creates several modernization risks. OS updates can introduce timing and behavior shifts by changing thread scheduling, memory handling, or service startup timing. Even small changes can expose race conditions that were never visible before. Driver and middleware sensitivity is another concern, as these components are often tightly coupled to specific OS builds. As a result, a security patch can introduce behavior changes even when no application code has been modified. There is also certification fragility to consider. Previously certified EMV, contactless, and other advanced workflows may no longer behave identically after an OS change, requiring additional validation and sometimes full recertification. The result is that deployers must repeatedly retest the same workflows, often under tight timelines and with limited hardware availability. Most ATM test environments were never designed for continuous OS validation. They typically assume stable operating systems, predictable service behavior, and limited regression frequency. In reality, however, these assumptions rarely hold true. Physical ATM labs cannot easily scale to validate every patch level. Manual regression testing often takes too long and becomes a bottleneck, and issues are frequently discovered late in the cycle, pushing risk into UAT or pilot deployments. This is why many OS-related failures are not caught until after deployment, when correcting them is both visible to consumers and very expensive. Paragon's virtual ATM platform is designed specifically to support continuous validation in advanced function ATM environments. Through virtualized XFS services, Virtual ATM simulates real ATM devices and service interactions, allowing teams to test OS changes without relying on physical hardware. This makes it possible to validate driver and middleware behavior across different OS versions, identify timing and sequencing changes introduced by patches, and test advanced function workflows under realistic conditions. Virtual ATM also enables automated regression testing at scale. Once transaction and workflow tests are automated, they can be rerun after every OS patch, across multiple OS builds, and without consuming lab hardware or field machines. This significantly reduces manual effort while increasing overall testing coverage. In addition, Virtual ATM supports certification reuse with greater confidence. By validating that behavior remains unchanged through automated regression testing, teams can focus certification efforts only where real changes occur. Finally, virtual ATM environments are available 24/7, allowing testing to run continuously without competing with development, UAT, or production schedules. The most successful ATM deployers have already made this shift. OS modernization is no longer treated as a one-time milestone, but as an ongoing operational change. Testing becomes continuous, automated, and repeatable, allowing teams to validate updates more quickly and consistently. At the same time, validation efforts focus not just on whether a transaction succeeds, but on how underlying services behave and interact throughout the workflow. Virtual ATM supports this operating model by aligning ATM testing with the realities of modern ATM platforms, where service behavior, timing, and integration between components are just as important as the final transaction outcome. Windows modernization for advanced function ATMs is no longer a project you finish. It is an operational reality that must be managed continuously. With every OS update, ATM deployers face the risk of subtle changes in XFS services, device drivers, middleware interactions, and transaction timing. Without a scalable way to validate these changes, even routine security patches can introduce unexpected behavior into production ATM fleets. Paragon's virtual ATM platform is designed specifically to address this challenge. Virtual ATM provides a fully virtualized ATM environment that simulates real XFS devices and services, allowing teams to test advanced function ATM workflows without relying on physical hardware. This enables organizations to validate OS patches and upgrades against real transaction workflows, detect changes in XFS service behavior before deployment, run automated regression testing across multiple OS builds, reduce dependency on limited ATM lab hardware, and test continuously without interrupting development or UAT environments. By virtualizing ATM devices and enabling automated test execution, Virtual ATM allows ATM teams to move from reactive validation to continuous testing aligned with modern OS update cycles. With Virtual ATM, organizations can reduce OS-related production incidents, validate Windows updates faster and with greater confidence, maintain certification stability across OS changes, and scale testing coverage without increasing manpower. In an ATM environment where Windows updates are constant and service behavior is tightly coupled to the OS, confidence comes from the ability to test continuously and to test at scale. That's exactly what Virtual ATM makes possible. Thank you for listening today.